nanobots, the vigilant doctor. Here we have childhood medulloblastoma. Now, it's a disease in which a tumor develops along the brainstem of, a child, and it normally ends up being fatal if not treated very extremely soon, and with chemotherapy, which does not always perfectly match the patient or meet their needs. Well, here I've designed a clinical trial for a new product. It is a treatment that is using the nanotechnology that we have at hand that will enable us to detect childhood medulloblastoma, not only detect but also to destroy and cure. Now, the clinical trial goes as follows, as this population would consist of children with medulloblastoma no younger than 4 years old, which, I mean, it's just an ethical policy for me because of the nature and the sensitivity of these patients. The benefit of this case study for the subjects would be their cure of medulloblastoma, which would be not only an amazing benefit, but it would also mean so much for the people that would follow them in their being cured of cancer, essentially. But should the product fail, the only real waste would have been that this time could have been used for those specific patients to undergo chemotherapy, which would have benefited them in their own right, rather than have their time be wasted. But the procedure actually goes as follows. After the subject is sedated with general anesthesia, the product will be administered intravenously to the lateral external jugular artery, and the whole of the nanotechnology devices, these nanobots, they will be controlled by a software that is prompted by a computer, equipped with a master kill switch that can terminate the procedure at any given time for the safety of the patient. And these will also be extracted with a specialized dialysis machine via the brachial vein medial to the left elbow after the course of the surgery. And this first wave of nanobots and this product would target the irregular membranes of cancer cells and would evaluate the constitution of the cell's outer proteins and their irregularity to determine the cell as cancerous, which will coordinate with the software in the computer. This first wave of treatment chemically marks the cancer cells on the brainstem of the patient to indicate the cell cluster as cancerous. And this chemical signature, it's non-toxic and totally unique and would never otherwise be found in the body. Now, as the nanodevices detect no more unmarked cancer cells, this second wave of treatment will be introduced. These new nanodevices will find these chemosignatures that was put on the surfaces of the cells and would actually physically disrupt the membrane while releasing a DNA disruptor, which would disable the nucleus of each cell cluster and the multiple nucleus of each cell cluster, ultimately destroying and neutering the tumor, absolutely devastating it. But specifically, after the cell membrane is broken, the nanodevices would release a chemical into that cell cluster. The chemical released into the cancer cells will cause the DNA to disassemble and break up the double helix shape, which is so vital and essential to the functioning of DNA. Now, this chemical will be totally unable to fit through a semi-permeable membrane, which would protect all of the healthy cells that are local to that area. Hence, why we have to mechanically and physically break up the cellular membrane. This is to be noted, there is a third wave of this product. Whenever there is a cellular debris, whenever there is tons of cellular debris of these cancer cells that are now dead, these will be chemically and mechanically processed by this third wave of product in this treatment, which would be much like a cleanup crew for this area, this tissue region, which would clear it all out and make sure that there are no more cancer cells to totally express the efficiency of this treatment. And all of these nanoproducts dissolve within the blood system at a controlled detonation. So after they've already marked, this cancer cells, such as in the first wave, and they've already cleaned up and demolished as in the second and third waves, they will all disintegrate within the bloodstream and then will be processed out with a specialized dialysis machine, which we have constructed. And the ultimate goal of this product is its actual success. Not only would we be wanting to cure these children, these test subjects, of their CM, but also their successors, these people that are going to come after them, who want this procedure, and that whenever this trial is approved, will become a product that all different types of cancers will will be able to be cured from. Essentially, with this product, we're curing cancer, which is a huge step in modern medicine, honestly. Cancer is hands down one of the most deadly diseases that plague the 21st century in these core countries that we have. And the main goal of this actual trial is to promote the product safety, because we want to make sure that if there are any improvements that we need to make on the software of the computer or the physical nanotechnologies themselves, whatever improvements need to be taken will be taken, and each measure will be carefully documented and considered and discerned for the improvement of this product and the ultimate cure to cancer. Current treatments such as chemotherapy wreak havoc on the body. Although it may kill a tumor and prove to be extremely effective in curing cancer, many do not benefit from it in where they suffer long, agonizing months of chemotherapy because it does not register well with them in their metabolism with the medicine, and it just turns into a long and sepulchral marathon in which the end usually results in death for the patient, unfortunately. And with this new product, that will be eliminated. Because it works on the cellular level, what that's going to do is that it's going to allow us to go in and not only be able to detect cancers before they manifest themselves as enormous tumors, but also make a much less painful and a much less painful and much less arduous procedure that that would be much more efficient in promoting health and for future. This trial's design, this trial would only have a single variable because it would be the qualitative measure of whether or not the procedure was done. A control or another variable would be either reluctant or irresponsible because of the sensitivity of these patients and their demography. Our subject selection, we would, for this trial in particular, we would actually more so branch out. And after this trial has undergone, we would then apply this new methodology to all different types of soft tissue cancers, which of course unfortunately excludes things like leukemia and different bone cancers. However, this does really help a lot of people. We intend to make a perfectly randomized population for our product in our trial, because that's going to procure the most reliable and the most replicable results. But however, there's one catch. We only accept people with cancer over 5 years of age for this trial, because of that sensitivity of those first 4 years of life and what that can mean for the patient and their health, because that is such a crucial developmental period. Because of the high sensitivity of this procedure, there's a close relay between the carefully assembled software on the computer and the nano devices themselves, in which, should there be any complication, can be terminated within a moment's notice, and ultimately the procedure would be totally safe for the patient and would not be capable of hurting anything other than their cancer. And conclusively, this procedure should be totally safe for the patient because of all the safety measures that are in place. Each person initially is actually also evaluated for things like allergies and specific conditions that would impede the effectiveness of the surgery. So what we would do would adjust the constitution of this treatment in order to actually fit their needs and their conditions to where they could benefit the most. The mass of the tumor also is put into consideration, as this would dictate the quantity of nanodevices to expedite the procedure, as more devices would be used to conquer more massive tumors. And here I have my conclusion questions. Oh, wrong button. Oops. Nope. Get a nice flash of my dashboard. Alrighty, right down here. Here we have, I'm going to go ahead and expand this window. Okay, here we have all my different answers. Yes, I would subject myself to a clinical trial because in a well-researched clinical trial, if I would be successful, I would not only benefit, but also, should I fail, I would also be a step towards progress in that regard. And with type 1 diabetes, a neat nano device that we could use would be to actually help the liver make insulin and glutamate to provide the patient with their own insulin, so that they don't ever have to worry about injections or contaminations or the wrong kind of insulin or anything like that. That way we could help the diabetic live their life to the fullest. Thank you so much. I appreciate it.